Hey, what's going on? This is another video for daily math training with Khan Academy. Khan Academy is the current math tutoring application or math learning application that I use to go over basic basic arithmetic and different types of math, going all the way to advanced calculus. I'm doing this because in graduate school for engineering, um, having a strong grasp of mathematics is important. And even though I graduated without a engineering degree, without having to take advanced calculus, I only had to take like introductory calculus. Um, I wanted to be able to find ways to, to have a better intuition of learning certain mathematical concepts. So that means that I have to pay attention to all the branches of mathematics, at least the ones that I need them for. So if you're interested in listening, you can follow this video or listen to the other videos in the that I have in the backlog. So let's go ahead and focus on that. All right. So here we are. We have one-step mathematics and calculus. This is the practice links. Let's get started. All right. So here we have solve the equation. It's 2 equals n over 3. All right. We can automatically look at n over 3 as this is which should be just expressed the same way, the same value of 2. So one way to explain the same value of 2 would be to either if this was 2, we know that 2 over 4 would be we go again, 2 over 4 would be similar to like 1/2. And then we also know that if we want to go ahead and make like 2 over 2, this also equals, well, actually this would probably just equal 1, but what I'm trying to basically get at is that the idea behind solving this would be to kind of focus on the division equation method, which would be to try to get n by itself. And that would basically mean to take 3, put 3 under here. And this would basically mean you would put 3 on the top, I believe, and then you would solve, you would divide it, cancel it out. This means canceling out. And then we would end up with n equals 2 over 3. And n equals 2 over 3 should be the answer we could use for this. No, it's not. So next thing we would have to go ahead and do is, can we get n by itself? Let's see. You solve 3. Oh, yeah. You have to solve 3 from both sides. And then once we get solve a 3 for both sides, you end up with 6 is over n. 6 equals n. So next you have is 9x equals 108. So we would put 9 on both sides. Yeah, that actually reminds me of what I have to do. So then we cancel this out. Actually what we do is that 9 divided by 9 equals 1. And it's like 2 by equals 1, or 9 over 9. This is just the other thing that we would also get. Now, looking at this without trying to figure out what 9 times something equals 108, the idea would be to just try to divide 108. Let me bring this, let me get rid of this. Actually, I want the other one. Yeah, object eraser. So we know that 9 divided by 8, or 108, we would do this. I mean, could, oh, let's do it. 108 goes into 9 0 times. You add the 0, and then we say 108 goes into 9 0 times, right? And we put the 0 there. And then we say something like 900, 108, or was it 108? Yeah. And then we say 108 goes into 912 times, and this is 12 times 108 is 900. And that's kind of like how we would go ahead and get 12. That process is, I don't necessarily do that process, but it's good to see that process works. And we can just put, this was 12 here. Reason why I like that process is because of the fact that it does lead to the answer. It leads to a different way of the answer. I wouldn't necessarily look at it, and that's important to uncover different methods for solving the problem. All right. So we have W over 5 equals 3, right? And then we have what we would do before is that we would want to try to solve, I think, solve for 5 on both sides. And then you would get 5 up here too. Right, and then we would get 5 up here, right? So this is what, okay, so I'm actually looking at it like the way we did the other actual problem. So we have 5 times 3 will be 15 over 5. And then we can say 5 goes into 15 3 times. And then we can say, right, and then we can say W equals 3. That's interesting. Does that work? Or would it be the other way around? No, I think it's the same way. All right, so let's try that out and see. No. So I did something wrong. Let's go back. And let's go back, and we have W over 5 equals 3. What happens is that we do take the 3 and we solve the 3 on both sides like that. Then we, this would get 15 times 3, right, which would be 15. That would be 3 W. That would be 1. Why is this? Why is it? All right, what am I doing? I feel like I'm doing it backwards. Yeah. I did have that I had to have that situation set up, which is W equals 15. Okay, so it actually would just be 15. So first, so what we do is that we have W over 5, this is 5 equals 3 times 5. And then, so when we have W over 5 equals 3, we take the 5 on this side, we multiply on both sides. Okay, and then after we do that, these two 5s will cancel out, and then we just end up with w equals 15. All right, so here we go. So let's try to focus on this. So we have 2e. Can you see that 2e? Yeah, you can. I think I'm going to change that color because that's too bright. Make it darker. Okay. So you have 2e equals 2. So let's do the thing we were doing before. We have 2e at the bottom. Now we can solve it on both sides. The reason we're doing that is that we are taking 2, canceling 2 out on the bottom because 2 equals 1e, right? Or e. That's the little mystery that actually happens when I'm doing the math. Like you don't really remember why you're doing that. And 1e equals e, so this can stay that way. And now we have here was 2 times 2 divided by 1. 2 over 2 is equal to 1, which is mean e equals 1. And then we can also check that this plug in this answer in here, which would be 2 times 1 equals 2. So if you remember in the last video, I was actually had a check that I was using. I'm going to add that check to my particular system of learning tools. So it's z over 2 equals 6. And then you have so then we have z over 2 equals 6. And what we're going to do is that we're going to take 2 and we're going to put 2 on this side, right? And then we're going to go ahead and do the math for that. So z over 2, I think we put we put 2 up here too to cancel it out. And then here we would get 3 because 3 times 2 is 6. And if we cancel this z out, we would get z right here. Z equals 3. And then, so z would be equal. Why I can't do that? All right, let me go ahead and use the other method that I actually was using. So we have z over 2 is equal to 6. And then you have 6 divided by 2. 6 over 2 equals 6. You would go ahead, would add the 2 on this side. This 2 on this side would lead to 3. And then we would have to, we put z on the top too. We'll put 2, we wouldn't put 2 on the top. Yeah, we would put 2. But what we're doing is that, I think that this is what I need to see. If we're saying that both of these are equal, what we do is that we take something like this. Now I can see that where would lead us to z equals 12 over 2, which is basically 12 over 2 is 6. But then how does z equals over 2 equals 6? It wouldn't be that, right? It would be z equals 12. All right, so let me go ahead and pull in another number. So here's 2, 2, would be 3. And then we would have z times 3, and they have 2 times. All right, let me go ahead and look at the actual head. So what happens here is that you have z over 2 times 2 equals 6 times 2. So we would have z over 2, and you multiply it by 2. Yeah, so it looks like what happens is that I'm kind of right. This does happen. But then what happens is that when we get to the second part, it says z over 2 times 2, and that cancels out. And that is what is very interesting. Why would, if I think it would be something like this, then, right? It would be z over 2 times 2 over 1. And then these would cancel out, and you would end up with z equals 12, because the 6 times 2 equals 12. Yeah. And then you put the 12 down. Yeah. Okay. So that would be the idea. All right. So what I was trying to get out of this whole entire thing was that I was trying to find a way to understand the smaller steps that are happening. Okay, so we have 6 equals k through 9, k over 9. So what happens is that first we will go ahead and we will add the, we will say 9 over here, and it will say 9 over here. Then we would know that 9 times 6 would be 54. And then we would know that 9 times 9 would be 9k over 9, like that. But we would cancel that out. And then we would end up with just k equals 54. And then if we wanted to plug in 54 into k, 54 over 9, we would know that 54 over 9 equals 6, because 9 times 6 equals 54. Yeah, so that's kind of where I was trying to actually pull that into play. So now I have a more visual representation of what's going on, and not the method, because I feel like the method falls apart in my head over time, because it just fades. But the pictures could will allow me to do it. Like, how do you, like, percent what I'm basically trying to kind of I'm trying to kind of come up with a theory that I can save this in my mind, very similar to how you know how to get home, from different parts of your life. So if you are on one side of town or the other side of town, there are cues or landmarks that you can use to know what to do next. And the idea is that when you're practicing, you're trying to put together a system that allows you to practice better. So let me go ahead and continue. All right. So right now we have just 3s right here. Now that we have 3s on this side, and we have 6, so what we're going to do, we're going to cancel. We're going to try to, what we do is we solve for s, and then we bring 3 on this side, which will lead to 2s. 2s. Yeah. And then we know that 3 times 2, well, we can use this. Once we know s equals 2, we could say 3 times 2 equals 6. Okay, so let's go ahead and run through that real quick one more time. Okay, if d over 4 equals 9, which basically means you would take 4, which ends with 4d over 4 equals 9 times 4. Whoops. equals 9 times 4. And 9 times 4 is 36. And then the 4D, we just end up with D on this side. We go ahead and we cancel that. We get D. Yeah, we put 36 on the side. All right, so we're gonna move to the next one where we have, I just hit that. Okay, good. We have 2 equals F over 8. And what we do here is that we take this F over 8 and we will put 8 on this side and you put 8 on this side. This is just like the putting it up the other way around where you solve for 8 on both sides. It's like solve for the denominator on both sides. And then you would have you would cancel those out, the F on the side, and then you would have 16 here. So because 8 times 2 is 16, and then 16 equals F. We can put 16 here. Let's try to do the next one. This one looks like it's going to be 1, but we're going to try to do it really quick. We're going to do this where we put 9 at the bottom, canceling that one out. And then we put 9 on this side as well. We cancel that one out. Well, we don't really cancel. What reason why we cancel doesn't mean that the number becomes 0, it becomes 1. And over here it becomes 1. So 9 times, yeah, because 9 divided by 9 is equal to 9 over 9. Okay. The next thing is you have y over 8 equals 5. And then you have y over 8 equals 5. And this would be where we would take 8, like we did up here. And then you have 8 on this side. This would lead to 40, because 8 times 5 is equal to 40. And then we have this would lead to just y, because these would cancel out. And then we can test that out by putting 40 over 8 equals 5. And we know this because we know that something 8 times something, right, equals 40. So we know that, so we can put that 5 in here. And then we can go to the next one. So we have here b over 6 equals 3. And then you have b over 6 equals 3. And then we would do the same thing again, where we wouldn't do the third. We're not going to multiply. I mean, we're not going to divide, we're going to multiply. So what happens is that the 6 we could place over here, the 6 we could multiply over here. This would lead to 18. This would lead to b, and b equals 18. And then we have 6g equals 48. And we would have 6 here. And then we would put, because what happens here is that we don't have g by itself, we have a 6 on the top. So we have 48 times 6. And that would basically be the same thing as canceling this out, you're getting g by itself. This actually would be dividing it. And now you have 48 times, you have 48 divided by 6. I know that 8 times 3 is 24. So 8 times 6 would be 48. So then we would have G equals 8. And then you have here it's 9, and then you have this is basically where we would do. This is actually interesting because this is actually doing the opposite of what I was doing before. What happened? Now we have a division equation here, and this is going to be we're going to, in order for us to work on this, they're saying that a over 7 equals 9 over 1. I could start by looking at 9 as being a fraction like this. We know 9 equals 9 over 1. That's exactly what that fraction represents. And since we know this, I could just make this a little bit thinner like that. So what we do is that now we do something else where we would have to find a way to get it to equal on both sides. So we would say we'll put 1 on this side and put 1 up here, and then you put 7 on this side, and then we would have to put 7 up here. This would lead us to 9 times 7 is 63 times 7. That would be A equals times A would be A. So we need to bring this down. Duplicate. And we have here, duplicate. And you would just end up with A over 7. Now, I think we can, since we have it like this, we can just, we can go back to what we were doing before, where we would have 7. Yeah, we put 7 over here, which would cancel that out. And then we say A equals 63 over 7. And then A was 7 is actually 9. All right. So because we have that, we know A equals 63. Yes. Yeah. So this question here is like used to help you to kind of think about what the next step would actually be. So you don't have to, ask for all the answers on your own, which is great. So what I want to go at, so what is my newest idea is that we would have A over 7 equals 9 is basically saying 9 equals 1. You would have a 9 on both sides. This would lead to A over 7 and 63 over 7. Then you would go ahead and you would add 7 on both sides and canceling them out, leaving just A equals 63. And then we know that 63 over 7 equals 9, because 9 times 7 equals 63. And there we go. So that pattern helped to go over all. I think that's all for one step, multiplication. The next thing we're going to work on is 2 steps and multi-steps. Wow. And then there's a quiz, and then there's one-step inequalities. There's a lot to do. I'm gonna see if I can try to get through it, get through this week. Is there 1, 2, 3, 4, oops. 2, 3, 1. Yeah, 2, 3, 4, 5, 6. Yeah. So I think I can probably get through this week. And then I can probably get through this whole thing this month. I can get through it. I'm hoping. And then I think the next thing I'll jump into would be basic geometry. you know, and I might play around with some programming to kind of help put these things into perspectives that allows me or someone else to kind of figure out what they need to do. So